The next type of stress is the thermal stress. And this is due to the change in temperature. So there are two ways of it. One is by heating a body or by cooling a body. Now on heating you will see that there will be expansion in length, whereas in cooling you will see there will be reduction in length of a material. So now from this the strain I can write E thermal. So what is the strain? Strain will be equal to, it is given by this equation, alpha into del T, where alpha is called as the coefficient of expansion, coefficient of thermal expansion, So now what is this del T? Del T is the temperature difference, that is T2 minus T1. If T2 is greater than T1, then it is heating. And in this case there will be expansion, so del L, that is change in length, it will be positive. Whereas if T2 is less than T1, in this case you will see it is due to cooling and there will be reduction in length, so del L will be negative in this case. So this is the difference. Now what is the length? The change in length. So change in length, the del L will be equal to E into L. Since we know this relation, del L by L, that is equal to E. So here this E is actually the thermal strain, so E thermal. So this will be equal to alpha into del T into L. So this is the change in length. Next is the stress, the thermal stress. So sigma thermal, this will be equal to E thermal into E, since we know sigma equal to E into E. So from this I can write alpha into del T into E. This will be the thermal strain. Then the expansion of material, it depends upon the coefficient of thermal expansion and it differs from material to material. Now for the aluminium, the coefficient of expansion, it is greater than that of brass, and the coefficient of expansion of brass is greater than copper, and this is greater than steel. So from this I'll give an example to you. Consider we have two materials, two bars. One bar is the brass and the other bar is the steel. Now if I apply the same amount of heat on both, so on heating you'll see that brass will expand more when compared to the steel because of the coefficient of expansion difference between these two materials. Then here you see I have considered a body which is fixed at both the ends, and now if I apply some heat on it, you will see that there will be tensile force, and at the same time there will be some reactions also from the wall, and this reaction will be actually resisting this force, and as a result you will see that there is some stress. So I can say the stress here, the thermal stress here, is not equal to 0 in this case. Whereas if I consider a body which is not fixed and it is under free expansion, so on heating this you will see there is expansion, there is tensile force here, and this tensile force is not being resisted by any other reactions. So here the body will expand freely. So this undergoes free expansion. So here in this case the thermal stress is equal to 0 since there is no resistance.